So now let's do a problem. Prove that the following function has at least one real root in the interval 4, 6. Okay, so here we have a function, and they want us to prove that it has at least one real root. What that means is that we don't know what the function looks like. We can graph it if we want to, but again, we don't have a graph at our disposal. We're going to use this theorem and analytical methods to show that this function actually crosses the x-axis at least once between 4 and 6. So it's either going to cross like this way, or it's going to cross this way, going from negative to positive or positive to negative. We don't know which one first, but we want to show that at least it hits the x-axis at least one time. That's what this says, has at least one real root. That means it hits the real axis at least one time. Now, the y value is going to be 0. That's what a root means. So in the interval 4 to 6. Okay, well, let's check our hypotheses. I think I'll do this in blue, actually. So, excuse me. Our hypotheses. Well, let's see. The first one is A less than B. Yes. 4 is definitely less than 6. Okay. Our second hypothesis. Our second hypothesis is f of 4 less than f of 6. Well, we have to check that. So f of 4 equals 1.643. When I put 4 into there, I get 1.643. And definitely make sure that your calculators are in radian mode, not degree mode. Because when you put in 4 in here, all the functions in calculus, when you use your calculator to solve a trigonometric function, make sure you're in radian mode. You'll get a number if you're in degree mode, but the number is going to be wrong. So f of 4 is that. F of 6 equals negative 1.497. So yes, this is true. F of 4 is different than f of 6. And hypothesis 3 is f of x continuous. Over the closed interval of 4 to 6. Well, yes, sine of 2x is a completely continuous function. Sine and cosine are continuous everywhere. Cosine is continuous, and we know that the sum or the difference of a continuous function is continuous. So yes, that is continuous. The hypotheses are satisfied. Therefore, there exists at least one number between 4 and 6 such that f of this number, some number, let's just call it c, there exists at least one number c between 4 and 6. There is some number here in that interval such that f of c is equal to 0. Because 0 is between 1.643 and negative 1.497. So f of 4 is 1.643, so let's just put it right there. F of 6 is negative 0.497, so let's just like put it right over there. The function is continuous. Because it's continuous, when I'm going from here to here, I cannot lift my pencil. Therefore, somewhere, doesn't matter what trajectory it takes, some path, whatever the function looks like, it has to pass through 0. That's what we're saying. So that's what the intermediate value theorem says. If A is less than B, if the f values are different from each other, and if it's continuous, that there's some number between the x values such that the f of that number is between the f values of the two numbers. That's it. Okay, thank you so much for joining us here at Educator.com.